Hello everyone, this video is for EL6303 probability and stochastic processes. Um, uh, Today we'll discuss the first two questions in homework 9. Let's focus on the first one. Suppose WT is a Wiener process and define the xt equals to WT minus 1 plus 1 minus WT. To solve three small questions. The first one, draw a couple of samples of xt. We know WT is a Wiener process, so it has one property that for large n, WT plus S minus WS is close to a normal distribution. So here we can write the xt is like this. So first, to draw a couple of samples, we can easily get these two graph. So the second question, to find the mean of xt and its autocorrelation. Here ext, we know that the mean of WT, Wiener process, is equals to 0. So here is 0. And then RT1, T2. We can expand this formula and get. Also here we know the autocorrelation of WT is equals to the minimum of T1, T2, and multiply along alpha. So here we can write these four terms like this. Then we should discuss four situations for the which is bigger. So here, if T1 plus 1 less than T2, and we can get the RT1, T2 equals to 0. And similarly, we can get the other three situations. Third one, to determine whether xt is WSS, SS, or Markov, and whether WT is with independent increments or uncorrelated increments or orthogonal increments. So WT Wiener process, it has one property that this process has stationary independent increments. So but for this mean of this, the multiply these two terms, we will not get it can multiply two means separately. So xt is not with uncorrelated increments or orthogonal increments. And since mean of xt is equals to 0, and r here rt t1 t2 is all about it's a function of the difference of T1 and T2. So xt is WSS, and by a fundamental theory, if xt is WSS and normally it can get xt is SS. So here we get xt is SS. Also xt is Markov process. Now let's focus on the second question. Let n be a Poisson process, and we define a new stochastic process xt. And then to explain these 5 small questions. So for the first, draw a couple of samples. We know xt equals to 1 when n is odd. Xt will equals to minus 1 if n is even. So here we can write the beginning of the we just focus on the beginning. It should be -1, and since the other may be stochastic. So let's focus on the second one to find the probability of xt equals to 1. So we can this probability equals to this probability where n is odd in 0 or t, namely k equals to 1, 3, 5, 7, and so on. So here we can write the basic sum formula and finally get the value of probability of xt equals to 1. And then to find the mean of xt, also this mean is equals to 1 multiply its probability and plus -1 multiply its probability. So this is mean of xt. Then to find the autocorrelation of T1 and T2. Here we can also use the previous way to get the final result. Here we know RT1, T2 is related to the absolute value of T1 and T2. Then to determine whether xt is WSS Markov or whether it is with independent increments or uncorrelated increments or orthogonal increments. So we know that ext, mean of xt is exponential function, not equals to 0. So xt is not WSS. Also, we find xt. About xt, past values have no influences on the future. It's only the future is only determined by the present value. So xt is Markov. Also, easily xt is not SSS. And then we can write the probability that this equality is satisfied, so we can derive that xt is with independent increments. Also, this result implies that xt is with uncorrelated increments, but we don't know whether the result is equals to 0 or not. So we cannot get so we don't know whether the result is 0. So xt is not orthogonal increment. That's all. Thank you.